What we did in the previous model was that we introduced a very simplifying hypothesis. We assumed only one good in the economy. And so the design of the model was very simple. What we are going to do right now is to make a more realistic assumption. We are going to suppose three goods, and this will be agriculture, industry, and services. And what you have to understand is that we will design a new structure of model with only, of course, three goods. But in fact, to introduce three goods, we change the structure of the model, and after that, it will be very simple to generalize to any number of goods. So this is what is really important here. We have to understand what will be modified by the introductions of three goods instead of one. First, this will modify the production block. We will have three production functions instead of one. So this is obvious, but another key implication is that we will have intermediate consumption and we will have an input-output matrix. That is to say, each sector will buy each good in order to incorporate fully this good in the production process during the period of production. Okay, so for example, the car industry needs steel, plastic, rubber in order to incorporate them fully in the production process. And this will also modify the final consumption block, because we will have to define a utility function depending on the consumption of three goods, which of course was not the case in the previous model. So I have to define a few annotations, in particular for the new endogenous variables of this model. There are also some parameters. I have to define also annotations for parameters, but I will do it later on. So let us focus on the new endogenous variables. Let us call VAI value added in sector I, PVAI the composite price of value added in sector I, and I will define what I mean by composite price of value added in a few minutes. ICI is total intermediate consumption in volume in sector I. PICI is the composite price of intermediate consumption in sector I. CIJ is intermediate consumptions of good I by sector J. And U is utility reached by the representative agent. So let me present right now the general design of the production block. Modelers used to represent the production process by a production tree. Here is the tree I would like to use in this model. This is very standard production tree. Of course, depending on what modelers want to do, modifications can be introduced. The first remark I would like to do is that the production tree here is the same one for all sectors. Okay, so it implies that we have the same structural relation in all sectors. Of course, some parameters may vary, but the structural relations are the same. And so you have to keep in mind that, of course, we can adopt a different production tree from one sector to the other. This is something that I did, for example, when we study biofuel mandates in European Union and the United States. But right now, I would like to start with something simple, and we adopt the same production tree in all sectors, so we will have the same structural relation in all sectors. Second, I would like to start with the top of this tree. This is output. So this tree means that to obtain output, producers need to mix value added and intermediate consumption. And then to obtain value added, we have to mix labor and capital, because these are the only primary factors that we assume in this model. Of course, we could introduce other primary factors like land or natural resources. We can differentiate labor in skilled labor and unskilled labor. To obtain intermediate consumption, in fact, we have to purchase each good. So here, intermediate consumption, total intermediate consumption is obtained through the purchase in each sector of each good. So we suppose here that each good is purchased by each sector. So the agricultural good is purchased by the agricultural sector, the industrial good is purchased by the agricultural sector, the services good is purchased by the agricultural sector, and so on. Third, we also have to make an assumption about the substitutability or complementarity of each component of the production tree at each level of the production tree. So, for example, at the top of the tree, we must decide if value-added and intermediate consumption are complements or substitutes in the production of the output. So it means that, do we consider that we can replace value-added by intermediate consumption, or that they are complements in the productions of this output? Here, I decide that there is a Leontief relation between value-added and intermediate consumption. You know, I think, what is a Leontief relation. It's a proportional relation between two variables in volume. So here, we've got two Leontief relations between output and value-added, and between output and intermediate consumption. And so it means that we have a proportional relation in volume between production and value-added, and a proportional relation in volume between production, output, and intermediate consumption. And we've got exactly the same kind of relation between total intermediate consumption and the intermediate consumption in each sector, of each good by each sector. That is to say, at the bottom right of the tree, we've got a Leontief relation between the intermediate consumption of the agricultural good, the industrial good, and the services good by each sector, and total intermediate consumption. On the left bottom, we've got value added, and what we suppose here is that there is a Cobb-Douglas relation between labor and capital for the creations of value added. What does it mean? It means that there is substitutability, and the share in value of each primary factor in value added is constant. So we will see what is the equation describing this relation in a few minutes. But it means that there is substitutability with elasticity of substitution between labor and capital equal to 1. So let me present right now the equation, which are the translations of the production tree that I just presented. And we start with the top of the production tree, which is the relations between output, value-added, and intermediate consumption. So you remember that we made a Leontief assumption. So here we have three relations between translating, in fact, the top of this tree. First, you have to understand that we make a distinction here between price effect and volume effect. And this is needed to understand exactly what happens in the economy. For example, if in reality we have a change in value added, you understand that it may come from a price effect or a volume effect. So, for example, if value added varies, it may come from variations of the prices, the remunerations of primary factors, capital and labor, or it may come from a variation in the volume used in the production process at constant prices. So it means that we must make a distinction in value added between volume and price. So this is why we define a composite price of value added, which is an average of the price of labor and the price of capital, and a composite aggregator in volume of value added. And same thing for intermediate consumption. We make a distinction between the composite price of intermediate consumption and the aggregate intermediate consumption in volume. So the first relation that is a translation of this, the top of this production tree, is the relation, the Leontief relations between value added and output. And so you remember that the Leontief relation is a proportional relation in volume between two variables. So here it is a proportional relation in volume between output and value added. So value added is a composite aggregator in volume of value added, and we have a proportional relation in volume between VA in sector I and Y in sector I. And I use a parameter which I call psi underscore VA in sector I, and so the equation is VA in sector I must be equal to psi underscore VA in sector I times Y in sector I. And we've got exactly the same kind of relation between output and intermediate consumption, a proportional relation in volume between output and intermediate consumption, total intermediate consumption. So here we have a relation which is IC in sector I must be equal to psi underscore IC in sector I times Y in sector I. So again, this is Y in sector I, so it is the output in volume, and IC in sector I is total intermediate consumption in volume, which is in fact the translation of the volume effect in the variations of intermediate consumption. And so it means that both relations imply that when we want to increase output in this sector, in volume, we have to increase proportionally the volume of value added and the volume of intermediate consumption. And the last relation is the fact that the revenues of the producers coming from the sale of the product on the market at price P covers exactly the total cost of production, part of it being value added and the other part being intermediate consumption. So we've got a relation which is P times Y in sector I must be equal to PVA in sector I times VA in sector I plus PIC in sector I times IC in sector I. And so we've got, for the value added, the price effect in PVA in sector I and the volume effect in VA in sector I. And same thing for PIC in sector I times IC in sector I. We've got the price effect and the volume effect. So let me now present the equation translating the bottom left of the production tree, that is to say the relations between value added, labor and labor demand and capital demand. So you remember that I suppose the Cobb-Douglas relation between labor, capital and value added. I just want to make a few preliminary remarks. We can of course change this assumption for another one, another kind of relation between value added, demand for labor and demand for capital. What is possible also is to differentiate this assumption from one sector to the other. For example, the Cobb-Douglas relations and another relations in another sector. And in some sector also we can add primary factors. For example, in agriculture we can add land because it's a specific factor to the agricultural sector. So in fact, general equilibrium models are flexible in this regard. So here we suppose something very simple, and we suppose that there is a Cobb-Douglas relation in all sectors. So what does it mean? It means that the share in value of each primary factor in value added is constant. So it means that we have three relations within each sector. So the first relation is in fact the expression of the Cobb-Douglas function. So the quantity of value added created in one sector I is equal to a parameter, which is a scale parameter, which is in fact the global factor productivity, times kd at the power alpha in sector I, times ld at the power 1 minus alpha in sector I. So it means that the sum of the powers is equal to 1, and we have a Cobb-Douglas relation because we have this type of relation, A times kd at the power alpha times ld at the power 1 minus alpha. And so this is the quantity of value added created from the quantity of capital and the quantity of labor incorporated in the production process. And you remember that if we make a minimization of the production cost, we obtain two relations, which are the demand for labor and the demand for capital. So from a cost minimization program, we obtain the quantity of labor demanded by sector I, and so it is such that W times LD in sector I is equal to 1 minus alpha in sector I times PVA in sector I times VA in sector I, and the demand for capital is such that R times KD in sector I is equal to alpha in sector I times PVA in sector I times VA in sector I. So we've got something that we have already seen in the computable general equilibrium model. I just want to add that if you add the last two equations, you obtain something which is PVA times VA is equal to W times LD plus R times KD. So it means that the value added is just equal to the total remunerations of labor plus the total remuneration of capital. So let us complete this work of translating the production tree into equation. So we have to work on the bottom right of the production tree, that is to say the relation between total intermediate consumption and the intermediate consumption of each good by each sector. So I also suppose that it is a Leontief relation, so it's again a proportional relation in volume between the top of the tree, that is to say total intermediate consumption, and the bottom of the tree, which is the consumption of one good by one sector. So I know what is the top of the tree. It is intermediate consumption in volume, a composite intermediate consumption in volume. So it is noted ICJ. And so we have a proportional relation between ICJ and what is at the bottom of this part of the production tree, that is to say the intermediate consumption of one good by one sector, which I call Cij of good I by sector J. And so the equation is Cij of good I by sector J must be equal to a parameter which I call psi underscore ijc of good I by sector J times ic of sector J. So you have to be very careful with the dimension because in fact it's a total intermediate consumption of sector J, and so you have to in fact introduce a new dimension, which is the dimension of the good which is purchased by the sector J. The second relation is a relation in value between the value of the top of the tree, which is the value of total intermediate consumption. So I'm going to call it ICJ times ICJ. So ICJ, you know what it is. It is total intermediate consumption in volume. So we have to define a composite price that reflects how the prices of intermediate consumption vary. So this composite price is called PICJ. And so PICJ times ICJ must be equal to, in fact, the price of the agricultural good multiplied by the intermediate consumption of the agricultural good by this sector, plus same thing for industry, plus same thing for services. So it is sum over I of the price of intermediate consumption, which is here P. So there is the same price for final consumption or intermediate consumption, times Cij I by sector J. And so we've got two relations. The first equation is a block of equation, and behind this block of equation there is 9 equations because we have two dimensions, I and J, which contains 3 elements. So it is 3 multiplied by 3. So you have got 9 equations. And the second block of equation, you have in fact 3 equations. The total value in agriculture of intermediate consumption, in industry, and in services. So I would like to check that this modification can be implemented in the model, in the sense that we have a number of new variables exactly equal to the number of new equations in order to keep a square system. Well, in fact, if you look at the previous slides, we've got 8 equations in the production block. And so, in fact, we have 7 equations which are defined of a single dimension, which is I, and 1 equation which is defined of a double dimension ij. So it means that we have 7 blocks of equation which contains, each of these blocks contains 3 equations, because there are three sectors, and the 8th equation is defined of I and J, and so you've got 9 equations behind this block of equations. If you look at the variables which are included in this production block, you've got the production in volume Y, the value added in volume VA, the total intermediate consumption in volume IC, the consumption of good J by sector ICIJ, the demand for capital KD, the demand for labor LD, the composite price of value added PVA, and the composite price of total intermediate consumption PIC. And 7 of this equation, of this variable, are defined over the single dimension I, and the 8th variable is defined of a double dimension ji, so you've got exactly the same number of new variables and new equation. I didn't talk about P, the price of the good, R, the price of capital, and W, the price of labor. This is because they are determined elsewhere in the block, in the market equilibrium block, which contains the market equilibrium for the labor market, for the capital market, and for the good markets. So let us now consider the final consumption block, how the introduction of three goods modify this final consumption block. So in fact there is the definitions of the single agent's income which has not changed. It is still INC must be equal to W times LS plus R times KS. So you've got the income of the single agent, which is defined by its supply of labor and capital, and we've got to take into account the remuneration of labor and capital given by market equilibrium W and R. And so the utility functions is now changed. I have assumed that it is a Cobb-Douglas function. So there is a second equation, which is the definitions of the Cobb-Douglas utility function. So I call U the level of utility reached by the agent when it has a level of consumption defined by Ci, that is to say the level of final consumption of good I. And so this level of utility is the product of a I of Ci at the power gamma, gamma being a parameter of the model, and it has to be calibrated at the beginning of the program. So if you derive the level of consumption that maximizes this level of utility, taking into account the budget constraint, this is very easy to demonstrate that the level of final consumption is defined by the relation P in sector I times C in sector I must be equal to gamma in sector I times INC, the level of the income. And so it means that the share of good I in the consumer's budget is a constant. So we just checked that with the modification that we introduced in the model, we are still sure that there are the same number of equations as the number of variables. So if you look at all the equations, of course you notice that the presence of the supply of capital and the supply of labor. The supply of capital is Ks and the supply of labor is Ls, but they are considered as exogenous variables, so they are not explained by the model. Then you've got a certain number of parameters, which the list is alpha I, gamma I, psi underscore VAI, psi underscore ICI, psi underscore IJC IJ, and also AI. So all these annotations are parameters of the model. I'm going to provide you with initial data, and you will have to calibrate all these parameters. And so this is an important part of the program. But we have the same problem as in the previous model, because in fact as the model is written, we have one equation which is not independent. So in fact we have n free variables and n minus 1 independent equations. So we use the same trick, I would say. We add a variable Léon to the equation, the same as the equation in which we introduced Léon in the previous model, and we fix a price which will be the numeraire, and this price Here I'm asking you to fix the price, the consumer price of the agricultural good. So you have the assignments that you have to include in the program, which is P.fx in sector AJR is equal to the initial price in this sector. So the agricultural price is the numéraire, and with Léon on the equations of market equilibrium in the labor market, we have the same number of independent equations as the number of free variables. So you need some data to fit the model. Here is the social accounting matrix, which is attached to the program that I would like you to write. So in terms of presentations of the social accounting matrix, you notice that there is a difference because there is no more one sector but three sectors. So you have 3 rows and 3 columns in the productions of goods and services chapter, and 3 rows and 3 columns in the chapter activities, agriculture, industry and services. But the rest of the social accounting matrix is the same as the previous one. So we start with the production of goods and services. So at the line activities, agriculture, industry and services, in the columns productions of goods and services, you see that there is a production of 5,000 in the agricultural sector, 11,000 in the industrial sector, and 9,500 in the sector services. And this level of production implies a remuneration of productive factors, so value added, and the payment of intermediate consumption. So you've got 2 times 3 matrix of remunerations of primary factors. So at the line, at the row labor, factors labor, you've got, for example, 1,000 of remunerations of labor in the agricultural sector, 2,000 in the industrial sector, and 4,000 in the services sector. And you've got also remunerations of capital, and then you've got an input-output table, which is the intermediate consumption of the good which is in row by the sector which is in column. So for example, you've got consumption of services of 500 by the agricultural sector, 2,500 by the industrial sector, and 1,000 by the services sector. So with the remuneration of primary factors, you've got payment to the owners of the labor primary factor, which is households. So you have a payment of 7,000, and the payment of capital goes to enterprises. But enterprises decided to distribute profits to households because the households also own stocks on enterprises. And so you've got a remuneration of household of 7,000 plus 3,000. So the total remuneration of households is 10,000. And so with this revenue, in fact, households consume. So final consumption of household is 2,000 in the agricultural sector, 2,500 in the industrial sector, and 5,500 in the services sector. So I would like to make one criticism to the model as it is written right now, and one comment. So first, the criticism. It's addressed to the final consumption block because the share of good I in budget is constant, because you can write Pi times Ci over INC is equal to gamma I, which is a constant. And so it's contradictory to observations, because in fact there is a law in economics, which is the Engels law. In particular, the Engels law implies that the proportion of income spent on food falls with the level of income. And so it means that income elasticity of final consumption is not equal to 1, except a few goods, but you've got, for example, income elasticity of food is less than 1, and income elasticity of final consumption of goods like leather, luxury goods is greater than 1. So it means that it's not a good assumption, a right assumption to this Cobb-Douglas in final consumption, and so we will have to change it in the next versions of the model. But it will be done during the second curriculum. I would like to make one comment. I didn't make any assumption about the state of competitions in the production block. Well, in fact, it is an assumption of pure and perfect competition. So to illustrate that, you can use the equation Pi times Yi is equal to PVAI times VAI plus PICI times ICI. So if you divide both sides of these equations by Yi, you've got something like price is equal to average cost, because on the right side you've got total cost of production divided by the level of production. And so you know that when price is equal to average cost, it means that profit is equal to 0. It means that, in fact, with the revenue from the sales of the production, the producer can pay for the intermediate consumption and can remunerate productive factor at a normal level, which is the level of the market. So it means that there is no profit. And you know also that with the Cobb-Douglas in the value-added function, you've got the sum of the power of the capital and labor, which is equal to 1, because it is alpha plus 1 minus alpha, and it means that there are constant return to scale, which is also a feature of pure and perfect competition. So I would like right now to explain the assignments that I'm asking you to do. So this assignment is to write the model. So be careful with the identifications of endogenous variables and also the equations. Be sure that they are the same number of equations and variables, in particular independent equations and free variables. You've got also LS and KS, which are exogenous variables, but you can, of course, in fact, declare them as parameters. This is what you prefer to do. And I gave you some data to feed the model. But you notice that you've got, in fact, not many prices. So you've got production of in the agricultural sector. You've got the value of labor. You've got the value of capital. But you do not have the price of the agricultural good. You do not have the price of labor. You do not have the price of capital, and so on. So what I'm asking you to do is to calibrate the model with several normalizations. So what is the normalization? It's a change of unit. It's a change of unit such that the initial price of a variable is 1. So it means that, for example, I give you an illustration. You've got the value of labor in this economy, which is 7,000. You do not know if it corresponds to unit of labor of, for example, 10, and a price which is 700, or maybe it's a price of 7 and a quantity of labor which is 1,000. So what you can do is simply to say that the initial price of labor is 1, And so the number of units of labor in the economy is 7,000. And so it means that you adopt a unit of labor, which is the quantity of labor you've got initially for $1, if it is dollar. So you see that you can apply normalization to each variable, capital, production of agricultural goods, and so on, but you can also apply normalization for composite aggregates, like for example value added, or the composite also intermediate consumption. I'm asking you to study the impact of a 10% augmentations of labor supply and a 10% augmentations of capital supply. Please, I would like you to evaluate the impact on, for example, GDP, but also the production in each sector and other variables of interest.